Now we're going to look at the graph of polynomials. If you remember, a polynomial is any function that just consists of a number times the power of x and then added together. Okay? This is the generic form of a polynomial. It looks a little confusing because we don't know how many terms there have to be. Okay? So hence why we have to put a dot, dot, dot. What we actually care about for this discussion, though, is just the very first term. So this is the term that has the highest power of x. The highest power of x is the degree. And the number in front of that power of x is called the leading coefficient. Now, there are two very special characteristics that polynomial graphs have. The first is what we call continuous. And continuous is when you can draw the graph without lifting up your pencil. Okay. The second is called smooth, or sometimes differentiable. Smooth is when you can draw the graph without lifting up your pencil and there are no sharp turns. So, I like to think of continuous and smooth graphs, the combination, as those we can build the kind of roller coasters I like on top of. So you can't have jumps, okay? You can't have the roller coaster all of a sudden not have tracks. You can't have sharp turns because they won't stay on it. And because I'm on the roller coaster, there's no loops or corkscrews. Now, things you can learn from looking at the leading coefficient and the degree. First of all is the number of zeros. If you remember, zeros are places where the function equals 0, otherwise known as x-intercepts. If the degree is n, we are going to have at most n zeros. Okay. Turning points. This is where the graph changes direction, so it was going up and it starts going down, or it was going down and it starts going up. And if the degree is n, we're going to have at most n minus 1 turning points. But there's actually something else about turning points. If n is an even number, say 4, not only do you have to have at most 3 turning points, but it has to be an odd number. So if the degree is 4, the possible number of turning points are just 1 and 3. Okay. So whatever we call it parity, even or oddness, the degree has, the number of turning points has to have the opposite parity. Now, end behavior is what the graph does on the ends. So we're not talking about the middle at all here. We're just talking about what it does on the ends. And it depends on both the degree and the leading coefficient. So, if the degree is an even number and the leading coefficient is a positive number, on either end, the graph will go up. It will look like this with crazy stuff in the middle, maybe. If it's a negative leading coefficient, it will go down on either end. Now, if n is an odd number with a positive leading coefficient, it will go down on the left and up on the right. And if it has a negative leading coefficient, it will go up on the left and down on the right. Now, you may say, how am I going to remember that? But you already know the graph of several kinds of polynomials. An x squared looks like this. A negative x squared is a reflection. We knew it looked like that. An x cubed did this. And a negative x cubed was a reflection and did that. So essentially, the end behavior mimics an x squared or an x cubed, and we already know how those behave. So let's make sure we understand how to use this information. We're going to see what kind of things we can glean from these graphs. So, this one. Okay, first of all, there are 3 zeros, which means the degree is at least 3. But there's also 4 turning points. So that means the degree is at least 5. Now, we're in this case an odd degree, and the ends match the upper one, so this means that the leading coefficient is positive. Let's look at this one. There are 2 zeros, so the degree is at least 2, but there are 3 turning points, which forces the degree to be at least 4. Because we have an even degree and they both point down, this tells me that the leading coefficient is negative. This one has 1, 2, 3 zeros and 2 turning points. Both of those pieces of information makes me think that the degree is at least 3. And the end behavior tells us that the leading coefficient is negative. Lastly, this has 2 zeros. So the degree is at least 2. And the end behavior tells us that the leading coefficient is positive. And we got all that information just by looking at the overall shapes of the graphs.